Okay, next up is problem 19. This is the counting Sundays problem. So it says you are given the following information, which is that the 1st of January in 1900 was a Monday. Then it tells you that there's 30 days in September, April, June, November. The rest of 31 except for February, which has 28, except on a leap year, which has 29. And it also gives you some information on when leap years occur. So leap years occur every year, evenly divisible by 4, so basically every year that's a multiple of 4. But not on a century, unless that century is also divisible by 400. And then the question is, how many Sundays fell on the 1st of the month during the 20th century? So from the 1st of January 1901 to the 31st of December 2000. So we need to count the number of Sundays that happened on the 1st of a month. So the 1st of January, if that was a Sunday, then that would have counted. However, actually that might have been, this was 1901, whereas that one was 1900. So I'm pretty sure there's, as part of the time module that's built in, I'm pretty sure that has something where like you can return the day of certain times, basically. But we're not going to use that because I have a feeling that'd make it too easy. So we're going to come up with our own way of counting Sundays, I guess. So yeah, that's what this one's going to be. So let's get into it. So first of all, we need to handle for basically the days. So we're gonna have a list of days. So days equals, and I'm just gonna type out the different days. Whoops. We got Monday, we got Tuesday, we got Wednesday, we got Thursday, Friday, Saturday, whoops, and we've got Sunday. Right, now we've got all the days. What we're going to do is we're going to say basically we're going to ignore leap years to start with, and we'll fill that in later. So what we're going to do now is we're going to run some program that will count all the Sundays that would have happened between the 1st of January 1900 and the 31st of December 2000, had there not been any leap years at all. So we're going to say so we probably need the months as well, actually. So let's make a thing of the months. So we're gonna have, and I'm just gonna put these to 3 letters. So we're gonna have Jan, Feb, March, April, May, Okay, so now we've got the months, we're going to need the years. So the years are going to be basically a list of numbers from 1900 to 2000. 1901 to 2000, sorry. So years equals, and that's going to be an empty list. I'm going to say for I in range 1901 to 2000. Years dot append I, and now I know that's wrong because I always get the like the inclusiveness wrong, but we're just going to print this and just find out exactly what this is. So we're going to print years, then we're going to call main, and then we're going to run this. So you see we get the years, we get 1901 but we don't get 2000, so what we need to do is we need to add a 1 to this, and then you see we get all the years. So now we've got the years, what we can do is we can say we probably need the number of days in each month as well. Maybe, yeah, we probably do need that. So if we say, we could write a different function for this actually. We could say define days in month. That's going to take in a month, and it's going to return a number of days, so length of the month basically. Now how it's going to do this is it's just going to check against the little poem that was typed up. So it's going to say we're going to have like 3 lists. So we're going to have months of 31. That's going to be equal to something. And now we're going to just copy this. We're going to have months of 30, and then February will have 28, and like I say, we're going to ignore the leap year for now, so that's how that's going to stay. Now the months of 31, we're going to have to type this up, so it's going to be, so it's, sorry, not 31, we'll do 30 first. So it says 30 days has September, so September's there. Then it's got April, June and November. So April, June and November. Now it says all the rest of 31, so we could just do like some else. So we could say like February is here, and then we could do like an else for up here, but I'm just going to type them all up. So we have January, we have February, we have March, we have May, we have, oops, we're not having February up here, sorry. February's in the 28 one. So we've got May, June, July, so July's next. We've got August, so why there's a double space there. September, we've got October, we got, November's already been done, so December, and that's our last one. Now for 28 we've got February, and what we want to do is we want to say if month in months of 31 return 31, elif month in months of months of 30 return 30, elif, we could obviously do an else here, but I'm not. Month in months of 28 return 28. Now obviously we get rid of this. This is just a thing that I typed up for reference. So yeah, now what we can do is we can say, so we're going to start at the beginning of this list. So we're going to say for I in years. Oh, so what we're going to, right, we're not going to have I, we're going to say for year in years. Then we're going to say for month in months. Then we're going to say we need to know the days in that month, so we're going to say we want to be inside. So what this is going to do, it's going to be inside the year for however many months there is. Now I want to be inside the month for however many days are in that month. So we're going to say for month in months, so it's going to be in that 12 times. Now I want to be inside each one of them like 30 times or so. So for day, in range, and then what we're going to do is we're going to call days in month, and we're going to pass in the month, and we're going to say, we'll just say print hold on, so we're going to iterate over the length of the, well, the range of the days in the month. So we're going to iterate over all the days. Now so the 1st of January 1900 was a Monday, so we want to say that basically what we want to do, we want to pop out this Monday, and then add it to the end and just cycle through these days. So we need a list of days past. This is going to be empty, and we're going to append to this as we pass through days. Now, list of days past dot append, and we're going to append days 0, and then what we're going to do is we're going to say list of days, days dot pop, days dot append, and then I don't know if this will work, but we're going to try it. Days dot pop 0. So what I want this line to do, so first of all we do this line. Now this line here, I want to append the first element of days to our list of days past. Now once I've done that, I need to pop that out of this first element, and I need to put it on the end, so it's like, obviously on Monday's been, so it's not going to be until 7 days later. Now to do that, I'm going to append it to the list, to the end, but the thing I'm going to append is the first element, so I'm sort of popping off the beginning and adding to the end. I'm not sure if it's going to work, but we'll see. So we'll just print the list of days past, and then to stop it doing absolutely loads, we're going to have this go to 1902. So this should do 1 year of days, and it looks as if it's worked. So we've got Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Now, if I print the len of the list of days past, we should get 365, which we do, so that's promising. Now, one problem is, so if I make this 2000, we're now going to get the entire list. So if I do this, it should run. So yeah, it runs pretty quick, so computation's not too bad. Now, one problem is that it gives us, if I bring this back up, it gives us that the 1st of January 1900 was a Monday. However, it doesn't want us to start counting Sundays until 1901. So we've got basically a year of days to fill in before we want to start counting. So let's see if we can do that. So what I want to do here is, you can't actually see all the code, my bad. Let me see if I can move that a little bit. Hopefully you can still see that. Okay, so what I want to do here is, I want to change this to 1900, but then I want to take away like the first 365 entries. So for I in range 365, list of days past dot pop, and then pop out the first element. So if I do that, it obviously should pop out 365 things. This also ought to be a 2001, didn't it, if I remember rightly? So let's see how this goes. And then once I've popped out those elements, I just basically want to count how many Sundays are in the list. So count equals 0. Now for I in list of days past, if I is equal to a Sunday, then count plus equals 1. And then at the end I want to print the count. Now this here should actually give us our answer, I think. So yeah, 5,214. That is way too many. Oh, wow. So if you look at the window, we've got 171. Which... Oh, okay. I'm completely missing the point. So, we need the number of Sundays that fell on the first of the month. And we also need to count for the leap years that I completely forgot about. Okay, so the answer we've got here is the number of Sundays that... whoops, you can't see the whole of this window either. There we go. So, the answer right here is the number of Sundays that actually happened between 1901 and 2000. So we need to count only the ones that happen on the first of every month. So how do we do this? So what we're going to do is we're going to say for day in range of days month, list of days past dot append. So we're going to make a new list. We have a list of first of month days. So this list of first of month days is going to be the list that we're going to use. Now we're going to append to this only if we're on the first day. So we're going to want to enter it once and then it is to be reset sort of thing. So we're going to need like a is first of month. Now this is going to be equal to true to start with, because we're going to actually, when we first enter it, it is going to be the first of the month, because we're going to enter this on the 1st of January. So it's going to be true. Now we need to reset this to true every time we change month, so right here. But every time we go into the day, we need to say if is first of month, we want to append our list of first month days. So it's basically going to be the exact same method right here. But then once we've done that, we want to say is first of month is then going to be equal to false, because we've just passed the first of the month, so it's not going to be that again until we move on to the next month. Hopefully this makes sense. So it comes in, it's going to be January. We know it's the first of the month because we're starting on the 1st of January. Now this is true, so we're going to come inside the days. It's going to be true, so we're popping inside this. We're going to append to our list of first of month days. Now once we've appended to that, we know we've now missed the first of the month, we've now passed it, so we need to set it to false. It'll now cycle through this little for loop right here until we get to the end of the month, in which case it'll then come out, change to the next month up here, and then reset this to true, so that we then get the 1st of February. Hopefully that makes sense. And then we continue. So I can actually get rid of this. We don't care about the list of days past. We only care about the list of first month days. So what this is going to do is, when I run this, this should tell us how many Sundays there were that fell on the 1st of the month between 1900 and 2000, not counting leap years, and obviously counting that one extra year at the beginning. So you see that's 173. So we're actually really close to our answer already. Our answer is 171 and we've got 173. So next up, we need to get rid of that first year, because obviously that's causing a problem. We don't want that extra year in. So to do that, what we're going to do is, see, what we could do is we could actually take our old list, our list of days past, pop out the first 365, find out what day the 1st of January 1901 is, because you see it gives us the information for 1900, this is the 1st of Jan. So if we actually find out this information here but for 1901, we could then just run the exact same program, but yeah, like with this list up here in like a different order, and then it would work. So actually I'll have it right here, won't I? If I So this would have been our first. This would have been our first year, right? So if this is our first year, then obviously the last day being a Monday means that the next year is starting on a Tuesday. So if I just pop out this Monday and put it into the end, whoops. And I then change this to 1901 and then run that. That should actually, so we got 171, which by fluke is actually the right answer. But I'm not going to stop here because that isn't actually right. Like, yeah, the answer's right, but the method isn't right. I haven't actually included leap years and stuff. So now we got that sorted, let's count for leap years. So what I want to do is I want to pass in this days in month. I need to pass in the year now because the days in February down here is affected by the year. Year. Now days in month, I'm going to pass in year. Now we're going to say if year mod 4 is equal to 0, then so basically what I'm doing here, right, is I'm going to read through this sentence right here, and I'm just going to type up the logic for it. So it says a leap year occurs on any year evenly divisible by 4. So first of all, we're going to code that. Let me just get rid of this because it's kind of in the way. I didn't realise. So any year evenly divisible by 4 is a leap year, therefore has 29 days, right? So we're going to return 29. Now it also says, but not on a century unless it is divisible by 400. So this only happens if it's not a century and not divisible by 400. So what I'm going to do is I'm going to code this sort of backwards. This is going to be like our last elif. So we need, if it's divisible by 400, so if year mod 400, not dollar, percent. If year mod 400 is equal to 0, then it tells us that it's a leap year. So return 29. Else, if it's not divisible by 400, but it's divisible by 100, then it tells us that it's not a leap year. Whoops. So we return 28. And now, if it's divisible by 400, it'll hit this. It'll return 29. That'll be the end of it. Now, if it doesn't hit this, it has the option to hit this. So it might be divisible by 100, but not 400. So it could be, for example, 200. Now, if that's the case, it's going to return 28 because it's not a leap year. Now, if it hits neither of these, it has the option to hit this final one. So if it's divisible by 4, in which case it is a leap year. Now, if it's none of these, else return 28. And obviously we can now get rid of this. So let's run this. And you see, obviously we get the same answer, so this is actually pretty terrible, but I'm happy now that the logic behind this at least is right. So how we could test this is if we print the len of the list of days past, we should see that it's longer now when we include leap years. So what I'm going to do is I will comment out all of that. I'll just return the 28 like it previously was. So we're going to run this. It tells us it's 36,500 days. Now, if I uncomment this and delete this, it should tell us that there's a couple more days in there. So you see we've got 25 extra days. So definitely including leap years. So yeah, that's it. That's this problem done. It took longer than I actually thought it would, but still wasn't too difficult. Just weird little logic up here, looping over the different days in the months in the year. Hopefully this makes sense logically, because obviously we're looping over the days in the month, in the year. It's basically just iterating over time. And like I say, if you want to look into an easy way to do this, I think the time module, so up here you do the import time. I think the time module has stuff in where you can like return the actual days of the like stuff. Basically, just go look up the documentation for the time module. I'm sure you'll find it. So yeah, leave a comment below if you get stuck, if you need any help. And that's it for this video. Leave a like if you like the video, subscribe if you want to see more. I will see you on the next video. Thanks for watching.